Okay, so it's time to start not just rotation configuration changes on Android by Nicole. Please start it.
Again, okay. Good morning. Ohayo gozaimasu. I'm Nicole Borrelli, a developer program engineer at Google, and I'm going to be chatting about configuration changes on Android, not just rotation. So the inspiration for this talk was actually that I heard whenever I heard people talking about ViewModels in particular, there was a lot of chat about like, oh, this is for handling when a person rotates their phone, and I was like, there's so many other things that can happen that can cause configuration changes, and so I was like, oh, I should try to put together a talk and clear up some of these misconceptions. So let's talk about what configurations are to begin with. So one of the most obvious things of configurations are the orientation. Orientation, and indeed a lot of the other ones, were named really, really early in Android. And so orientation is not necessarily linked to the way that the device is held, but is about the property of the window. Which is similar to screen width and height. So screen width and height is more like the window width and height. So if you go into split window, that changes the screen size. There's a screen layout, which is not only which is the general size of the screen. It tells, and there's also bits in there about if it's a particularly long screen or if it's a round screen, which you would see a lot of time on with Wear OS. And it also has bits describing the direction of layout, so either left to right or right to left. Font scale is something that the user can change. You can make it so that you have a smaller font scale so that you get more text onto the screen. Or you can make it a little bit larger so it's easier to read. And this is one of the reasons why we like to encourage people to use SP rather than DP so that the scaling works out properly. Similar to font scale is pixel density. And you might think, oh, a Nexus 4 has this particular type of pixel density and a Pixel has this particular type of pixel density. But actually, there's a setting called display size. And the way that the display size makes it so that the UI can be larger or smaller. And it implements this by changing the pixel density of the device. So just to keep that in mind. And then there's also the UI mode. So UI mode is typically like on a device, on a phone device, it would be probably normal, but then there's also TV, there's VR, and there's also bits in here about whether night mode is enabled. So these are some of the properties about what a configuration is. So, but let's talk about what changes when you're going through a, like what causes a configuration change and what are the things that are changing when that happens. So the obvious one is rotation. And this is just, it's very common, which is why people think about it. The orientation obviously changes, but also the screen size changes because what used to be the height of the screen is now the width of the screen, and what was the width is similar to the height. Another thing is split screen and multi-window. Again, this changes the screen size because the window. It can change. It could change the orientation because the window could end up being wider than it is tall, so it could, or taller than it is wide, shifting from landscape to portrait. And it can also change the layout because it might be much smaller, and so it drops from the normal bucket to a small bucket for resources. Picture-in-picture is sort of the extreme example of this. When you shift into picture-in-picture mode, you end up with a much smaller window, which is usually much wider, and so you go from portrait mode to a small screen that's landscape and much smaller. Multi-display is really fun. Imagine taking your Pixel and you plug it into a projector. Now all of a sudden the screen size has changed, the layout has changed, now it's on a TV. The UI mode has changed. The pixel density has changed because pixels on a projector are usually much larger than on a handheld device. And in this case, even the touch screen has changed because you can no longer interact with the UI that's being projected. And this might seem a bit odd that someone would be plugging your app into a projector, but there's another really fun way that can trigger multi-display changes, which is foldable devices. So now you've got devices where the front screen might have completely different pixel density and size than when it's opened. And even beyond like these types of devices, can also see something similar to this with like a Pixel book or a Pixel slate. So you have a Pixel book and it's in the clamshell configuration, and you open it up to be a tablet, and now the keyboard isn't accessible, so you get a configuration change about the keyboard going away. Something similar happens with the slate if you disconnect it from the keyboard. So these are some of the common ways that users cause configuration changes. So what can we do about this? Well, the obvious answer is we can do nothing. And in some cases, in many simple cases, the system does pretty well handling the configuration change for you. It reloads the resources, and things like edit text will automatically save their state into a bundle, the key value store. But there are some UI components which don't do this or don't do it like you would like for your application, and so it can end up being a little less configurable and maybe can lead to some unoptimal user experiences, particularly if, say you have a paginating list view. The user scrolls a bunch down, the list view doesn't save its state properly, and then there's a configuration change, and the user ends up back at the top of the list, and that can be frustrating. So maybe not do nothing. So the first way is to use on instance state. There's three general ways that you can handle configuration change. You can use on save instance state, you can use the view model, or you can try to handle the configuration change yourself. So let's go and take a look at each of these. Using save instance state is important to do sort of no matter which approach you do, because it's how you're going to allow the user to continue their experience if your app is killed because of memory pressure or other reasons that the system would kill it. The main downside about using just instance state is that the amount of state and the type of state that you can save is limited. bundles can only save primitives in floats, strings, and objects that implement either serializable or parcelable. And it can be slow in certain cases. On a device where you're just rotating it every so often, it's not going to be so bad. With an Android app running on Chrome OS and resizing the screen, you can have hundreds of configuration changes in only a few seconds, which can be not so awesome. The next option is to use a view model. And this is really great because now all of a sudden you've got your state saved in RAM. So it's there. You can connect it to your UI with like live data and data binding. And because of this, because the data isn't being released or being serialized and unserialized, it's much faster. The main downside for this is that if your process is killed because of low memory, the view model will go along with it. And so in that case, you still need to save the state that you need to bring the user back to where they were in the bundle. So let's take a look at how one might use ViewModel and save instance state together. So we've got this great little app. And so what you might do is you might have in the ViewModel, you might have your ExoPlayer instance that's playing connected to like a player view or a texture in the activity. You've got the video metadata, and you've got the list of related videos, the metadata. You probably wouldn't want to put your adapter in here because the adapter ends up having links to the view structure, and that can lead to memory leaks. For what to store in the bundle, on the other hand, we want to save just enough state to bring the user back to where they were. So in this case, it's the URI that they're playing and the position that they are. So if you're more interested in more of the details about view models, live data, and data binding, definitely check out Florina's talk at 2:50. It's going to be in this room. Now, there are some cases, for example, games, where you might want to handle the configuration change on your own. So handling the configuration change on your own is obviously the fastest way because the activity isn't recreated at all. The downside is that this can be very complex, and there can be a lot of edge cases and results that you wouldn't expect. So how complex is the next question? Well, it really depends. So let's say that we have a very simple app. It has a constraint layout-based system. It's using all vector drawables. And we just want to handle screen size changes. We can probably do something like this, where we just, in our manifest, add in config changes is screen size equals screen size, and then we're done. Because of the way that our layout is constructed, we don't necessarily need to do anything on configuration changed. So rather than have no code in there, we can just leave it out and have it be a no-op. And this is great, but what if we, for example, wanted to add picture-in-picture support? So we go in here, we say, is picture-in-picture supported? Yes. And then we try it out. And it doesn't end up so great. And the reason is that we're not handling all of the configuration changes that are happening when we're going into picture-in-picture mode. So we can solve that. Like I said before, the orientation is changing because the window is getting wider than it is tall. and the screen layout is changing because we're going from a normal size screen to a small screen window. And because we only have the one layout, this is pretty much all that we needed to do, and now it works. But let's say that, yes, one more thing. Even if you don't declare that you handle configuration changes, when the user touches on a picture-in-picture window like this, the system will call on configuration change and report the new window size. It won't ever restart your activity for this change. It just tells you about it. Entering and exiting picture-in-picture mode will cause your activity to be recreated if it's not handled. So now let's say, now this is a really simple app. So let's make it a little bit more complex by adding in bottom navigation. So we've got this, we enter picture-in-picture mode, and not so great anymore. We probably should have a different layout that doesn't have the bottom bar in it. So now we should probably do something on configuration changed. So the first thing we want to do is in onCreate, we want to save a copy of our configuration. The reason for this is that once onConfiguration change has been called, even though it passes in the new configuration, it's already been applied. So there's no way to say, like, get the configuration and check what's changed in the new one. So to do that, we want to save a copy ourselves. Set2 is great. It just makes a deep copy of the object. So now we can add some code to actually handle the configuration change. So we say, okay, if the screen layout has changed, because we have two different layouts in this one, we have a layout for small screens and normal size screens. So all we have to do is, because the configuration has already been applied, we just have to call setContentView, and it loads the resource just like you would expect in onCreate. Now we have to reset the state because it's a different layout. So we get the keyboard, we get the toolbar, we check to see if it's showing or not. Then we reset the toolbar, set it as the support action bar, and then if it was hidden before, we hide it again. The toolbar is actually being toggled. The visibility is being toggled on picture-in-picture mode changed. That's why you don't see it here. And yeah, so now that we've done this, it works again. But this is, kind of a lot of code that does something that's very simple. So it's probably not done in the optimal way. You probably want to try to share as much code between on configuration change and on create as you can. But still you can end up with edge cases where you have different, if a new layout is being inflated, to make sure that all of the views are present, because if you miss that, it can lead to poor user experiences or just crashes. So with this in mind, how should we decide what we want to do here? So saving instance state is something that we probably want to do no matter which choice we choose, because even if you're going to handle the configuration change on your own, if the process is recreated, then you want the user to be able to pick up where they left off. ViewModel is great, particularly paired with the instance state. You get to save all of your state in memory, so you can pick up it can respond to the configuration change very quickly, but you don't have to write all of the code to do the tricky handling of reloading resources and that sort of thing. Imagine responding to locale changes and having to go through and reload all of the strings in your text boxes. And handling it yourself is an option, but it should be weighed very carefully. Like I said, with games, it can be important, particularly if you handle just a limited set, but of configuration changes, because there are some games where if the user is constantly seeing their activities recreated, it would not be such a great experience either. But just keep in mind the edge cases that can come up here. And then if you do handle it yourself, make sure to share as much code between onCreate and on configuration change as you can. The main takeaway I'd like to have from this talk is don't take for granted what can change after your activity started. Anything can change. As we talked about, the screen size can change, the font scale, the pixel density seemingly of the device, the touch screen can go away, the keyboard can go away. So with that in mind, I really, really recommend using ViewModels to handle configuration changes. It makes it so that you don't have to worry about a lot of that stuff, but you get most of the benefits of having a quick restart without having to worry about reloading things yourself. If you do decide that you want to handle the configuration change yourself, really test, because configuration changes can happen in very unexpected ways, as we found out. And making sure to get everything right is really important to have a good user experience for our users. Yeah. Okay, and with that, thank you. I guess we have a little bit of time for questions at least.